I'll next set up my drill press and use a 1/8 inch drill bit to drill the positions. I will insert this bolt in the center hole of the drill press table, and it has a piece of cork on the end to protect the plate. Then I'll use my gauge to set the depth on the drill press and then drill each one of the holes. I now have all the holes drilled to the depth required. Now I would take my gouges and start hollowing out the inside. This is where this pad comes in handy. If your tool is not sharp and you put too much pressure on it, and if you don't have a one piece, you could split it. Even a one piece, when you get thin enough, it could split. But a lot of times glue joints fail in the center when you're putting so much pressure on to remove the material. Remember, do not use a lot of pressure. Your tool should be sharp enough to cut with just a slight push. Here you can see the area that I've started gouging out. I used a 1/8 inch brad point bit, so the pilot was only 1/16 in diameter. When I started out, I had a hole this large, and when I get within 1 millimeter of the bottom of that hole, it decreases in diameter. That lets me know when to stop. After I get the whole plate gouged out, then I will come back with finger planes and clean up all the way down and check the calibration and the tone of the plate as I work. Here is the completed RTV silicone support mold that I made for the back and top plates. It works pretty well, and you have about a 1/4 inch of material in between the lowest point in the arch and the bottom, and it holds the plate in place with little or no movement. As you use it, it will get dirty, but you can always just take and wash it with soapy water and make sure that it is dry before you use it again. I have completed roughing out the inside of the back plate. My next step is to go in and flatten the area with the finger planes. The finger planes have a radius sole. Radius from one end to end, side to side. I have various different sizes that I'll be using to obtain a nice smooth flowing contour where everything is blended together at the different graduation points. I'll start out on a side and work my way in with very slight pressure just to take off the high spots. One of the things you need to watch out for is tear out. If the material actually starts tearing out instead of cutting, you need to resharpen your plane or change direction. I will continue this operation until I have the graduated area flattened to where the holes, the pilot holes, are just barely visible. I completed lowering the inside, gouging it out, and then with finger planes smoothing it out until I have a pretty smooth contour. To set the diagonal line position, draw a line from the widest point of the upper bout to the widest point on the lower bout. So the first diagonal runs this direction. Lay your 1-inch ruler on that line that you first drew. Draw your second line. And continue that process until you have all your diagonals set. The diagonals on the back go from the left top to right bottom. While we're here, I'm going to lay out the sound center of the back plate. Once you have your X in the middle of the two lines to set your diagonals with, measure 15 millimeters from the X toward the end pin. The sound center is 15 millimeters below the X of the two diagonal lines. It is actually the thickest part of the plate, and when you tap that section of the plate and activate, you get a tone. As you go up, you can hear the tone go more hollow. As you go to the left and right, you can hear the tone changing. Since the sound post will be in approximately this location here, this is where we want to move the sound center of the end of this plate to match that sound post, so that when the instrument is played, the force is being applied at the sound center of the plate. By planing and scraping the material, you can actually move the sound center over very easily.